Chapter 14, Kinetics, Exercise 14.61. The decomposition of SO2Cl2 is first order in SO2Cl2 and has a rate constant of 1.4 times 10 to the power of -4 per second at a certain temperature. What's the half-life? We are given the value of K, the rate constant. Half-life is just Ln2 over K. That's it. Half-life is 4950. 4950 seconds. How long does it take for the concentration to decrease to 25%? Well, 25% is 1/2 of 1/2. To halve the concentration, we need 4950 seconds. So we're gonna halve this 2 times. The first 4950, we cut the concentration to 1/2, and then another 4950, the concentration is gonna be reduced from 1/2 to 1/4 of the initial concentration. So that's why we need 9900 seconds. Part C, if the initial concentration is 1 molar, how long does it take for the concentration to drop to 0.8? I'm going to show you the equation. The concentration of A at time t is going to be the initial concentration. Somehow I need to delete everything first to use this calculator. Alright, multiplied by an exponential function of -kt. This is the equation. And we have 0.8 molar here at time t, so I'm going to use 0.8 here. We have 1.0 molar here as the initial. Alright, and then we just need to solve this. Let's see, do we have the value of K? I don't think so, but it's here. K is 1.4 times 10 to the power of -4. So we do have the value of K. It's 1.4 times 10 to the power of -4. So this is 1.4 times 10 to the power of -4. It's just I don't want to have exponential in the exponential term. That's gonna be too many layers of exponential. So just solve this, work at time, and I'm going to take the logarithm of both sides. Alright, the logarithm of the right hand side would be just this. That's it. Let's solve this. And what's t? T is ln.8 divided by this whole thing. Alright, so I'm going to copy this ln.8 divided by that. Somehow it's hard to do copy and paste in this online calculator. So 1590 seconds, or 1600 seconds. You can just run it up with 2 sig figures. It's just because over here we have only 2 sig figures there. If the initial concentration is 0.175, what's the concentration after 190 seconds? Again, we're just use the equation. The initial times the exponential function of -kt. That's it. This is the equation. I think we have K. K is 0.00014. The time 190. Alright, make sure you have used the units consistently. This K is in second to the power of -1, and this is in second, so we have a unitless exponential term, which is good. And now I'll get 0.17, very good. That's it. And I think Mastering Chemistry used logarithm to do some intermediate calculations, and I didn't. I just used this online calculator and this formula, the initial concentration times e to the power of negative kt, to get the answer.